the plan. On Wednesday, you have a senior assembly during second period. And while you're supposed to be back for third period, we all know that usually the chant rallies go way over the allotted time that they're supposed to take. So we're going to try to do 2 days of notes in 1 day, and we're going to try to catch up the avid people that were gone. So we have 2 days to try and cram 3 days of material and catch people up. So I want to start by doing a couple examples off the homework just to get us all on the same page about how to do second derivative test. Because if you don't understand second derivative test, you're not going to understand anything after that. So let's do did y'all do 1 on Friday? No? A couple people did? Okay. Did anyone do number 4 already? Okay, let's do 4. So, people that were gone, the notes are on the website. So if you need to go write those down, I'm going to put it on here. It's missjoyner.weebly.com. Okay, because I don't know how to use Google, so I like Weebly. Okay, but if you go on there, it says notes for the date, and you can look at them, write them down. Okay, number 4, you are going to take the derivative twice. Okay, this is a nice, easy polynomial. What's the derivative of f? Okay, yes. Now give me the equation. 8x cubed minus plus? No, nothing. Good. Okay, next one. Derivative again. 24x squared minus 8. Let's take out a GCF. We're setting it equal to 0. Take out an 8. What's left over?
3x squared minus 1.
Oh, wait, that is a 3. Okay, 3x squared minus 1. Okay, from there, I would need to factor that. 3 is not a perfect square, so I'm going to just set 3x squared minus 1 equal to 0. Add the 1 across. I get 3x squared equals 1. Then I divide by 3. I'd have x squared as a third. What are my 2 critical numbers? Plus or minus the square root of a third, yeah? Now, if this was a nice, easy, perfect square, that would have been a little bit easier, but it's not. So you'd break it down into 1 over 3 positive square root, 1 over 3 negative square root. Okay, then set up your line test. Negative 1/3 square root and positive 1/3 square root. Now, I need to pick numbers that are bigger than those and smaller than those for my sign chart. So I'm going to call this f double prime. I'm going to call the top f. Let's plug in, I don't know, 10. Okay, because 10 is going to be bigger. I'm going to be in this little part right here. What's 10 squared? Times 3? 300 minus 1? Positive, which means this interval is positive. Now, what we learned on Friday is that the second derivative tells you if the graph is concave up or concave down. Which one is it here? Concave up. Okay, in the middle, if this one's positive and that one's negative, I'm going to pick 0. So what's 0 squared minus 1? Negative, which means in the middle, if my f double prime is negative, f was what? Concave down. And for my interval over here, I'm going to pick negative 10. Negative 10 squared is 100. 300 minus 1 is positive. So I can see there that my graph changes from concave up to concave down to concave up. Now, I think I said that. I said that right. Okay. Look at your instructions. You want to find all points of inflection. Did we find them? Yes. And then identify intervals where it's concave up and concave down. So my concave up would be these two. My concave down would be in the middle. Does that make sense? Okay, so I'm going to put, these are both POIs. Because f double prime changes sign. Okay, next one that we're going to do is going to be number, let's just do 5. Okay, take the derivative twice, set it equal to 0, and then set up your number line for me. Number 5. It's only a point of inflection if there's a sign change. So you can't determine it's a point of inflection until you see that the concavity does change. So f prime would be 4 times the fourth is 1x to the 3 minus 2 times 2 is 4x. Second derivative, 3x squared minus 4. Okay, then from there, you can still factor that if you want to. It'd be root 3x plus 2 and root 3x minus 2. Even though 3 is not a perfect square root, you can still break it down, which means what are my two possible points of inflection? Negative 2 over root 3 and positive 2 over root 3. Now remember, there's only really a sign change there though, or there's only really a point of inflection there if there's a sign change. That's where you do your interval chart. So, negative 2 over root 3, positive 2 over root 3. Since I want to pick a number that's for sure bigger than that, I'm just going to pick 10, because 10's easy. Okay, you can plug in here, or you can plug in here. Doesn't matter. Okay, I'm going to plug in up here because I don't like all these square roots. 10 squared is 100. 300 minus 4. What do I get? Positive. Now I'm going to pick 0. 0 times 3 is 0. Minus 4 is negative. Next I'm going to pick negative 10 because I know that's on the left. Negative 10 squared is 100. 300 minus 4 is positive. That means my graph goes from concave up to concave down to concave up. Did I find 2 points of inflection? Yes. What if it went from plus to plus? Would it count? No, but that didn't happen on this at all. Okay? I guess we can do number 6. Number 6 is going to be a little bit harder, but we did several like it in your notes on Friday. So what would you have to do first to be able to take the derivative of number 6? You would have to rewrite it. X plus 1x to the minus 1. Okay, remember, you do not want to do quotient rule unless you have to. So if I can rewrite that as x to the negative 1, that's better. Okay, what would f prime be? 1. What about negative 1 times 1? Minus 1x to the what? Negative 2. Very good. Now, if I was doing a first derivative test, I'd get a common denominator, blah, 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 but I'm doing second, so I'm taking the derivative again. What's the derivative of 1 in the front? 0. Derivative of this back part would be negative 2 times negative 1. What's that? 2x to the negative 3, or 2 over x to the 3. From here, remember that your critical numbers, okay, even though they're not really called that for the second derivative test, okay, but they can come from the top or the bottom. What will make the top of that 0? Nothing, but the bottom would be 0. Remember yesterday or Friday, we called these PPOIs. If you were gone on Friday, that stands for a possible point of inflection. How does it become a point of inflection if there's a sign change? So you'd set up your number line here. Let's say I pick a number bigger than 0. Say I pick 1. What is 2 divided by 1 cubed? Positive or negative? Positive. What is 2 divided by negative 1 cubed? Negative. Which means that my graph goes from concave down to concave up. So do I have a point of inflection at 0? Yes. POI at x equals 0. Okay, and then remember the reason why would be, I'm going to write it again like I did up here, because f double prime changes sign. Okay, yes. You took the second derivative, set them equal to each other, you got the sine and the cosine. I'll help you with that, not right now though, because that one I think is maybe going to lose people. But we will do it. Remind me tomorrow and we can do that. Okay, you are now switching to your white sheet that you picked up on the way in. Huh? Yeah. Some of them are. Some of them aren't. Never know. Your notes for tomorrow are yellow. Okay. Concavity. So let's talk about, on Friday we talked about concave up and concave down. What that tells you is if the function slope is increasing or whether the slope is decreasing. So if you want to think about it like this, concavity, since it's the second derivative, is it's like the slope of the slope. Yeah? Okay? Don't overthink it. It's the slope of the slope because you took the derivative twice. So I would like for you to draw this graph. And then I would like for you to draw this graph.
Just do like that?
Yep. Okay, based on that little chunk of graph, I want you to tell me if the function, we're going to just do this one first. Is my derivative positive or negative? How do you know positive? That's correct, because f is doing what? Increasing. Now let's talk about the second derivative. We're about to write this down in a second. Is my second derivative positive or negative? How do we know? Because it's concave up, yeah? So I'm going to put f is increasing. So f prime of x is greater than 0. F is concave up. So f double prime of x is greater than 0. Then you would say that f is increasing at an increasing rate. My y values are getting bigger, and they're getting bigger at a faster and faster slope each time. Okay, now I want you to write those same two statements, but for the graph on the right side. What would change? F is what? Increasing or decreasing? Okay, what does that tell us? Okay, that f prime is greater than 0. But then look at your concavity on that little chunk. It's concave what? Concave down. And if it's concave down, then what do we know? F double prime is less than 0. Okay, so you would say that f is increasing at a decreasing rate. So it's increasing, but its slope is getting smaller each time. Okay, so think about your graph here. Okay, if I were to think about my slope at each of my points, okay, it's steep, then it gets less steep, then less steep, then less steep. So this graph is getting flatter. Yeah? Now, look at your other graph. What was happening there? Your graph was getting what? Steeper. Okay, those should be okay. Pretty obvious. Okay, I want you to now draw these two graphs. This one and this one. Okay, what would I say for the first one here? F is what? Yes? Question? Yep. Okay, what would I say for my first graph? What is F doing? Decreasing. What does that tell us about F prime? F prime is less than 0. What about concavity? Concave down. So F double prime is also less than 0. Okay, we're going to skip this last statement for right now. Don't write anything here. Okay, go over to the graph next to it. What would you put? F is what? decreasing. So f prime is less than 0. But f is concave up. So f double prime is greater than 0. Okay. I'm going to write the last sentence for both of these, and like half of you are going to be fine with it and the other half of you are going to want to argue with me, so just wait until I write it down, and then I'm going to try really hard to explain it, and I need you to just pay attention all the first time. So this one, you would write f is decreasing at a decreasing rate.
It's decreasing less and less each time.
What?
It's decreasing like
Hold on.
less and less as it goes on.
Yes. I don't know.
Hold
on, I'll explain it in a second. Now write down the opposite for this one. F is decreasing. I know it seems backwards. I'm going to try to explain it to you. Okay, write it down. And now everybody listens at the same time, so I don't have to say it 100 times. Okay, so let's do this graph first, yeah? What's my slope, positive or negative? This one, it's negative, yeah? So let's say here my slope's like maybe -5, yeah? Okay, then what happens here? Maybe it's only -4, then -3, then -2, then -1, then 0. As I count from -5 to -4 to -3, what's happening to the value? It's actually increasing, because -5 to -4 is an increase. -4 to -3 is an increase. -3 to -2, that's an increase. So the reason that it is decreasing at an increasing rate is because your slope is getting closer to 0, but in the negative numbers, that counts as increasing. Does that make sense? Yes?
So, like the one right there?
Yep.
So, although it's getting steeper, it's going from like -2 to 3.
Yes, perfect. So think about here. Maybe that's only -1, then -2, then -3 slope, then -4 slope. Is my graph getting steeper? Yes. But is the slope increasing or decreasing in value if my numbers are getting to be more and more negative as I go along the graph? My numbers are actually decreasing. Does that make sense? Okay, so now, is that the same as me saying that this is getting steeper? No. Steeper is like the absolute value of are your numbers getting bigger or smaller without the sign. That's not what this says. So if it's decreasing at a decreasing rate, your graph is going to get steeper. But it's going to get steeper which direction? Down. Up here, if I'm increasing at an increasing rate, my graph was getting steeper. The reason why is because your first and second derivatives had the same sign. They were both positive or they were both negative. So write steeper right here. Okay, why were they getting steeper? Because your first and second derivative had the same sign. Now look at these two graphs. This one was increasing but concave down. What was happening in the graph? It was getting flatter. But now look at this one. I'm decreasing but I'm concave up. What was happening in my graph? It was getting flatter. Why was it getting flatter? Because one of my derivatives was positive, the other one was negative. They were fighting against each other. That flattens out your graph. Make sense? Yes?
If the first graph was exponential growth,
Okay.
what would the second one be
on.
considered?
No, remember the derivative of e to the x is still e to the x. So the first and second derivatives would actually be identical.
Oh.
Yeah. But that's like a very weird situation that happens. Usually that wouldn't happen. Okay, any questions about that part? No? Okay, I'm going to write down, you should have written steeper, and then you should have written flatter. And then I would put over here because f prime and f double prime, same sign. Okay, poor English, but you get the idea. Okay, versus over here, how do we know they're getting flatter? Because they were opposite signs. Okay? Come down to number 17, please. Number 17. Okay, it says, for all x in the closed interval, f has a negative first derivative and a positive second derivative. That tells us two characteristics of our graph. It tells us increasing or decreasing, and it tells us concave up or concave down. What does a negative first derivative tell us? Okay, look at the graphs. Which one is not decreasing? Well, we want our y's to be decreasing, yeah? So 15, 13, 11, 9. Are those going down? Yeah, 15, 14, 12, 9. Yeah? Which one's out? D. Okay, that one is not decreasing. Okay, now how should the second derivative be? That means it's concave up. Think about your signs. If I'm decreasing but I'm concave up, will I be getting steeper or flatter? How do I tell? Based on if they're the same sign or if they're opposite signs. So if one's negative and one's positive, my graph should be getting flatter. Now, if you don't like that, draw a picture. If I'm decreasing and concave up, that looks like this. Yeah? What's happening to my graph? It's steep, then it gets flatter. So look at your jumps in your y. I went from 15 to 13. How many did I go down? From 13 to 11, how many? 11 to 9, how many? 2. Is that getting flatter, steeper, or is it a constant slope? That's a constant slope each time. So A is out. I want to be getting flatter each time. Look at B. From 15 to 14, how many did I drop? From 14 to 12, how many did I drop? Then 3. Is that consistent with getting steeper or flatter if your drops are decreasing or they're getting bigger in size? That's a steeper. Because I dropped 1, then I dropped 2, then I dropped 3. That's getting bigger. Okay, now look at C. I want to be getting flatter. I dropped 3, then I dropped only 2, then I dropped only 1. So that would be my graph getting flatter. Make sense? Okay, there's a question like that on your homework. Go ahead and do it for me while you're thinking about it. Very last one on the back side. Okay, then when you are done with that, for some reason, I don't know how to use a copier, and the back side of your notes didn't copy, so we're going to have to write it down. So when you're done, do that one first, then you're going to copy down the table that I'm putting on here. Getting smaller each time, correct.
So whatever the first derivative is.
So first derivative tells you increasing or decreasing. Second derivative tells you the concavity. If they're the same type, if they're both plus or both negative, then they're going to be getting steeper. your jumps will be getting steeper, and if they're opposite signs, your jumps will be getting flatter. Yeah? Huh? Yes. What are y'all getting? B is correct. So if you got B on that one, good job. Okay, from here, you are going to be back on the back side of your notes, and it's a part A, part B, and a part C. I went from 2 to 3 to 4. Yeah. Yeah.
Is this all that's going on the back?
Yeah. Well, and then there is a part D, but I haven't decided if we're going to do it. We'll see. Okay, you have it written down? Getting there? Colton, what's wrong with you? Wakey, wakey. You guys didn't nerd out like everybody else. What, too cool? Oh, you're an athlete. Okay.
I'm an athlete. Athletes dress like dogs.
Some of them do. It's true. Okay, you ready? Okay. Critical numbers. What is a critical number? How do you find it? If it wasn't a table, pretend it was an equation, you would take the derivative, set it equal to what? 0 or undefined. Look at your chart. When is the F prime row 0 or undefined? It's 0 at 2 and it's undefined at 4, yeah? So I want you to come over here and put your critical numbers. X equals 2 and X equals 4. Now then it says from there to label each one as a min, a max, or neither. So in my chart, okay, circle your 0 and your D and E. These are my critical numbers. Before the 0 point, what was the sign of F prime? Was it positive or was it negative? It was positive what number? 4. After 0, what was the sign of F prime? Negative. What happens then at X equals 2? It was a max. Very good. So even if you don't have the equation, you can still determine if it's a min or a max based on the way the sign changes around. So for X equals 2, I would say it's a relative maximum because F prime changes from plus, to minus. It's a relative or a local maximum because F prime changes from positive to negative. Now, around our X equals 4, the slope is D and E at 4. But how does the sign change? It's negative on the left, then it's what? Positive. And so if it's from negative to positive, what happens at 4? You have a local or a relative minimum. Because f prime changes negative to positive. Does that part make sense? Good with that? Okay, find your points of inflection. How would I find a point of inflection? I take the second derivative, set it equal to 0 or undefined. So look at your f double prime row. Where is it 0 or undefined in this row? X equals 3. Very good. Write it down. And then around 3, is there also a sign change? Yes. What is it on the left? Negative. What does that tell me about f? That it would have been concave down. But then on the right side, what is it? Concave up. So I would say I have a point of inflection at x equals 3 because f double prime changes sign. Okay, now, question. Do I need to say the direction it changes sign? For points of inflection, no, because it doesn't matter which way it changes as long as it changes sign. Okay, come down to letter C. Letter C says, use the tangent line at x equals 1 to estimate f at 1.1. So that part you should already know how to do. What am I going to start with if I want to write a tangent line? 2 things. Okay, point and a slope. Now, what is the x of my point? It was given to you. 1. When I get the y of my point, will I use f, f prime, or f double prime? F. So I'm going to put right here, use f row. If I want the other half of my point, I need to find f of 1. So look at your chart. What is f of 1 equal to? 3. Okay, when I want my slope, which row will I be looking at? The derivative, which is f prime's row. So look at 1. What is f prime at 1? 4. Very good. F prime of 1 is 4. So write the equation of your tangent line for me. So I'd have y minus 3 equals 4 is my slope, x minus 1. And then what do I do with the random decimal that they give me? You're going to plug it into your tangent line. So what is 1.1 minus 1? Good. 4 times 0.1 is how many? 0.4, yeah? And then what do I do with my minus 3? Plus 3, plus 3. What is 0.4 plus 3 more? 3.4. Okay, I want you to pay attention now. This is an additional question that's added at the end. Is your estimate greater than or less than the actual value? Okay, the way that you determine this is with concavity. I want you to look back up at your chart. What is f double prime at 1? Negative 1. It's negative. What does that tell us then about f? What does the graph look like? F is concave down. Draw a section of graph that is concave down. Would look like this, yeah? Where is your tangent line going to fall if you draw it onto a concave down graph? Will your tangent line be above the graph or will it be below the graph? Okay, here's my, I'm going to say I'm tangent here. We'll just pretend. Where's my tangent line? It's above. So if f is concave down, then my tangent line is greater than f of x. Anytime your graph is concave down, your tangent line is always going to cut above the curve. No matter which x you're at, that's always going to be true. Okay, we are now going to do the exact same thing, but at x equals 5. So I'm going to put same question, but at x equals 5, and you're going to find f of 4.8. So everything else is the same. We're just changing the point and then what we're plugging in, and everything else is the same. So x equals 5. I want an equation of a tangent line. What two things do I need? Point and a slope. How do I find the other half of the point for 5? Which row? F. Look in your table. At x equals 5, what is f of x? Also 5. Next, I want my slope. At 5, what is the value of the slope, or f prime? 3. Write the equation of your tangent line, then plug in 4.8. So it'd be y minus 5. 3 is my slope. X minus 5 again. Then from there, I'm plugging in 4.8. What is 4.8? Take away 5. Okay, good. So it'd be 3 negative 0.2. Then from there, what's 3 times negative 0.2? Negative 0.6. And then how do I get rid of a minus 5? Add the 5. What is 5 minus 0.6? 4.4. Very good. Okay, I want you to now think about that second question, just how we did it last time. Hello? Yeah. I do have John. Oh, I think she's actually, she's in the second period, right? She's in my other class. We're in third period right now. No worries. Okay, bye. Okay. What is f double prime at 5? Concave up. Or, I'm sorry, it's positive, which means the graph is concave up. Where will a tangent line be if my graph is concave up? It's going to cut below. So if you draw in your little line, wherever you want to put it, it doesn't matter. Your tangent line will fall underneath when your graph is concave up. So I would put tangent line is below actual value because f is concave up around x equals 5. Now, something very important here, you cannot be concave up at one point. So you need to say around 5, the graph is concave up. You can't have concavity at just one point. So you just say around 5, my graph is concave up. That means my tangent line is below. Okay, what I'd like for you to do now is flip that paper over, and we're going to write that in the little notes section on this sheet. Remember the little thing we skipped? Okay, so right here it says concavity also determines whether tangent line lies above or below. Draw a concave up graph. And then draw your tangent line in. And then write tangent line is below. And then you're going to write the exact opposite thing. If it's concave down, then your tangent line would fall above. Okay? So almost always when they ask you a tangent line question, they're going to put those 3 parts. Write the equation, plug in a random number, then say if it's above or below. So you'll be using concavity to know if it's above or below. Okay? All right. Great. Yeah, we don't have time for the other thing. But let's do then that one that you wanted to do. Look at your homework at number, what was it, Jasmine? Okay, look at number 8. Okay, take the second derivative and then set it equal to 0. Now remember, for sine and cosine, you're doing your snow cone, snow cone. Okay, what is f prime for sine x plus cosine x? Okay, cosine x minus sine x. Okay, now I have to take the derivative one more time. Good, negative sine x minus cosine x. Then for second derivative test, I set that equal to 0. And this is where it can get a little tricky to know what to do from here. So I'm going to help you find the possible points of inflection. We're going to take our negative sine x, we're going to bring it across to the other side. So now positive sine x needs to equal negative cosine x. So far so good? Okay, I want you to think about, I want sine and cosine to be what in the middle? Equal. Which finger on your hand, which finger is going to make sine and cosine equal to each other? Pi fourths. Do you understand why? Because I'd have root 2 over 2 and then root 2 over 2. So pi fourths is the one that I want. However, can they both be root 2 over 2 to make this true? What about that negative, right? They have to be the same number, but they have to be opposite signs. So that means I can't pick pi fourths. I need to pick the quadrants where they're opposite signs to each other. So let's draw our little all students take calculus. Circle for me the 2 quadrants where sine and cosine do not have the same value, either both plus or both minus. Which 2 do I want? Okay, here they're both positive, that means they match. I don't want that. What about here? Yes. What about tangent? They're both negative. I can't have that. What about cosine? Cosine is positive, sine is negative. So there are 2 places that happens. If I want multiples of pi fourths, because remember, I need sine and cosine to both be root 2 over 2. Then what would it be here? This would be 4 pi fourths. So then what would 1 less than that be? 3 pi fourths. And 7 pi fourths. Very good. Because think about, if this is 4 out of 4, then this would be 8 out of 4. And then minus 1 would be 7 out of 4. So 7 pi fourths for the other one. Now, when you do your line chart, we're only going 0 to 2 pi. So I'd put 3 pi fourths maybe here, and then 7 pi fourths here. Okay, can you plug in 0 if it wasn't a critical number? Yes, you can. So let's use 0. So ready? We're checking for the sign of f double prime, which is right here. I'm plugging in 0. Ready? That's my test point. What is the sine of 0?
0.
Minus the cosine of 0.
Negative 1.
It's negative 1. Because the sine of 0 is 0. Cosine of 0 is 1. 0 minus 1 is negative 1. Put a negative right here. Now, what is between 3 pi fourths and 7 pi fourths that would be easy for me to plug in? I'm going to pick pi, because it's easier. Okay? Pi is my number, right? Because that'd be 4 out of 4. That'd be in the middle. Okay, what is the sine of pi? 0. But what's the cosine of pi?
Negative 1.
Negative 1. If I do 0 minus negative 1, what am I going to get? Positive in the middle. Yeah? And then over here, when I get to 2 pi, well, 2 pi and 0 are the exact same angle. So if this side came out negative, what's the 2 pi side going to come out to be? Negative as well. So your graph goes from negative to positive to negative. Remember, those are the signs of F double prime, so what does that tell us about F? Concave, down, up, down. So if you were identifying your points of inflection, they would be at 3 pi-4 and 7 pi-4. Okay? That one was hard. Most of them on there are not that hard. Okay, do not do the back of your homework. We're going to